So welcome again. In this session, we are going to discuss a problem on secant method. So the problem reads, find the solution of the equation by secant method to correct to nearest four significant figures if the root lies between 1.6 and 1.7. Now, the first step, remember to apply secant method, so note to apply secant method, we need two initial approximations to the root. That must always be clearly stated. And then the second method itself is given by xn plus 1 is given by xn minus 1 f of xn minus xn f of xn minus 1 divided by f of xn minus f of xn minus 1. This by definition. Where xn minus 1 and xn are the two initial approximations. Now, because we have been given the interval where the solution lies, so I want us to use the bisection method to be able to know the first two iterations to the root of this equation. Remember, when we were deriving the secant method, we say that the two initial approximations may be given to you, or sometimes you may be asked or may be required to find them on your own using any of the previously discussed approximation methods. So 1.6, 1.7 is where the root lies. So the first approximate or the initial approximation of the root x0 will be the average of these two values, which gives 1.65. Now, remember the value of the function at 1.6, we calculated and found out the answer to be negative 0.144. So this is a negative value. And then the value of the function at 1.7, when you work out, you get 1.203. I remember the equation is x cubed plus x squared equals to 10 minus 2x. So we rearrange this one as x cubed plus x squared plus 2x minus 10 equals to 0. And so what we are calling the f of x is this function. So this is what you are calling the f of x. So f of x is x cubed plus x squared plus 2x minus 10. So when you put x for 1.6, you get this value, and when you put 1.7, you get this value. So this is positive. So indeed, our solution lies between 1.6 and 1.7. So we have 1.6 and then 1.7, and then here we have 1.65. So sign of this is negative, sign of the value here is positive. And so we need to determine the sign at 1.65. So when you put 1.65 into this function, you will get 0.514625, which is a positive value. So this is plus. Now in these two subintervals, to know where the solution lies, we simply pick that interval where the value of the function at the extreme points or at the end points have opposite signs. So this is where the root lies, but root cannot be between 1.65 and 1.7 because the values of the function at those two extreme points are both positive. So which means then x1 lies between 1.6 and 1.65. And to be exact, x1 will be the average of these two values, 1.6 plus 1.65. So dividing this by 2, you will get 1.625. So therefore now, the bisection method has helped us to get the two initial approximations to our root. So therefore we say the two initial approximations are x naught equals to 1.65 and x1 is 1.625. So when n equals to 1, then the formula becomes x2 equals to x naught f of x1 minus x1 multiplied by f of x naught divided by f of x1 minus f of x naught. I'm simply putting n equals to 1 in this second method formula. So with this, x2 will be given by x naught is 1.65, and then f of x1 is 0.181640,625 minus x1 is 1.625, f of x naught is 0.514625 divided by 0.181640625 minus 0.514625. Now use your calculator to confirm that x2 will be given by 1.611362677. So remember, you have to get the value of the function at x2, and this value, when you put 1.611362677 into f of x, you'll get 0.00310,158,14 1.57. So which is a positive value. So remember, just the way we were interpreting intervals where the solution lies in the bisection method is the same thing we do here to know which values we need to pick. So when n equals to 2, the formula becomes x n. N is 2, 2 plus 1 is 3. So we'll have x3 is given by x1 f of x2 minus x2 f of x1 divided by f of x2 minus f of x1. Just to make things clear, once you have the initial approximations for x0 and x1, then the rest of the iterations really do not have different interpretations of the positive and negative signs of the function, because we are just going to be increasing the values of n and using the previous two approximations to get the new approximation. So with this formula, x3 will be given by 1.625 into 0.00310,158,1457 minus 1.611362677 0.181640625 divided by 0.003101581457 minus 0.181640625. With your calculator, confirm that x3 should give you 1.61125,769. Now, if you round off x3 to nearest 4 significant figures, you get 1.611, and x2 you get 1.611. So we are okay to stop at this point because x3 and x2 have the same value rounded off to the required accuracy, and hence conclude that x, which is the solution for this, is 1.611, correct to 4 significant figures. If you have time, also just confirm that when you work out x4, you get 1.61124,291, which also gives 1.611 to nearest 4 significant figures. So hence the solution to the equation is 1.611. Thank you.